It's Saturday here at the Hazeltons, and as you can hear, the washing machine is going in the background. But my homework isn't just laundry, it's to get your video done so you can get your homework done. And today we're going to talk about angles and dot product. Pardon the washer noise. With 6 kids and 2 adults, well, only 4 kids live in the house, but 6 people living in the house, there's so much laundry that sometimes I lose the kids in it. Don't worry, Jamie, we'll get you out eventually. Anyway, let's say that we have 2 vectors. A has components of A1 and A2, right here, and vector B. It has components of B1 and B2. So if I put both of the vectors so that they both start from the same point, this vector is this one here, and if I wanted to find a name for this vector, it starts here and ends here, so the vectors that make it up must start here and the second one must end here. So it has a length of, let me get my pen out, right here. It has a length of, this has to be its starting point, so that's negative A, and then this vector has to end at this end point, and that's positive B, so that's negative A plus B, or B minus A. That's magnitude of that is the length of this vector. So now we have something, we know 3 sides. One side is vector A, one side is vector B, and one side is vector B minus A. Actually, it's the magnitude of all of those. It's not the vector, it's the magnitude of the vector. That is the length of the 3 sides. And so we have side, side, side. And what that allows us to do when we have side, side, side is we can use the law of cosines to find the angle, or to find an angle. In this case, we're going to find this angle. So don't forget the vector A has components A1, B1, and vector B has components B1, B2. So if I want this angle here, I need to use the side across from it to set up the law of sines. So using the law of cosines. Using the law of cosines, it'll be this side across from the angle squared equals the length of my other 2 sides, the sum of them squared, minus 2 times the magnitude of both sides, cosine theta. I'm going to show you how to find a formula for using the law of cosines to find the angle between any 2 vectors, but you don't need to write all this down. I'm just showing you where it comes from. You can write the final formula down when we're finished getting there. Okay, so hold on tight. This is going to take a lot of math to get through. Remember, you don't need to write this down. I'm just showing you where it comes from. So if I want to find the magnitude of this vector, I need to find the distance between the x and y components, and I'm going to use the distance formula. So the distance between those 2 points is going to be B1 minus A1 squared, those are the 2x components, plus B2 minus A2 squared, the y components. And then I have to square it because my whole term is squared. Alright, so I'm rewriting this in a form I can actually eventually simplify. Alright, now for this term, the magnitude of A. Well, the magnitude of A is the distance between the x and the y component. So that's going to be A1 squared plus A2 squared and I have to square that as well because that's squared in my formula. And then I have plus, same thing for b, b1 squared plus b2 squared, and I have to square the whole term, minus 2 magnitude a magnitude b cosine theta. I'm going to leave these as magnitudes because it suits my purposes. Okay, so I can now I can cancel out the square and the square root, and I'm left with b1 minus a1 squared plus b2 minus a2 squared equals, and when these squares cancel out, I'm left with a1 squared plus a2 squared plus b1 squared plus b2 squared minus 2 magnitude a magnitude b cosine theta. I can also expand these terms, and I get b1 squared minus 2b1 a1 plus a1 squared. And when I expand this term out, I get b2 squared minus 2b2a2 plus a2 squared equals a1 squared plus a2 squared plus b1 squared plus b2 squared minus 2 magnitude a magnitude b cosine theta. Whew, I managed to fit all that in one line. Okay, now I can really simplify it. If I subtract a1 squared from both sides, I have one here. I can also subtract a2 squared from both sides. That is over here. I can subtract b1 squared from both sides and b2 squared from both sides. And that leaves me with negative 2 b1a1 minus 2 b2 a2. And that is all equal to negative 2 magnitude of a magnitude of b cosine theta. And over here I can factor out a negative 2, and I'm left with b1 a1 plus b2 a2, and that equals negative 2 magnitude of a times the magnitude of b cosine theta. And finally, I can divide both sides by negative 2, and I'm left with b1 a1 plus b2 a2 is equal to the magnitude of a times the magnitude of b cosine theta. Okay, this right here, I'm going to circle it in red. That's called the dot product. And that's what we're going to work with today, as well as finding the angle between two vectors. So to find the angle between the cosine of the angle between two vectors, if I divide both sides here by the magnitude of A and the magnitude of B, it's going to be B1 A1 plus B2 A2 over the magnitude of A times the magnitude of B, and that's how I find the angle. I would find this first, and then I'd take the arc cosine of it. So the dot product's usually written as A dot B, which means I could also write my formula over here as A dot B, not multiplication, but dot, over the magnitude of A times the magnitude of B. So for the first example, I want to find p dot q, and here are my two vectors. P is 2, 3, and q is 1, 4. So you'll remember the dot product was a1, b1 plus a2, b2. So that's the first component here, 2 times 1 plus 3 times 4, which gives me 2 plus 12, which is 14. So the dot product is going to give you a scalar number. It's not going to give you a vector, it's going to give you another scalar. Okay, so let's do q dot p first. Q dot p is going to be 3 times negative 1 plus 2 times 5, which gives me negative 3 plus 10, which equals 7. For b, q dot r is negative 1 times negative 2 plus 5 times 4, which gives me 2 plus 20, which is 22. For c, I have q dot p plus r. Well, I need to find p plus r first because of PEMDAS. P plus r is going to be 3 minus 2 and 2 plus 4, which yields me 1, 6. So when I do q, it's negative 1 times 1 plus 5 times 6, which gives me negative 1 plus 30, which is 29. And last, I have d, which is 3r dot q. I need to take care of the 3r first. Let's do that up here. 3r would be negative 6 and 12. So 3r dot q is going to be negative 6 times negative 1 plus 12 times 5, which is 6 plus 60, which is 66. Hopefully you got all those correct. Hopefully I got all those correct. So looking at the formula for the angle between two vectors is cosine theta equals the dot product of a and b over the magnitude of a and b. Perpendicular vectors are when the angle between two vectors is 90 degrees. So I'm going to ask you, first of all, what is the cosine of 90? The cosine of 90 on the unit circle is the x value at 90 degrees, and the coordinates here are 0, 1, so the cosine of 90 is equal to 0. So if I have the dot product over the magnitudes, when will this fraction equal 0? When does that happen? Well, if it equals, the only time this fraction is ever going to equal 0 is when a dot b equals 0. That's the only time that fraction will ever equal 0. If it's 0 in the denominator, well, it's going to be undefined. So the only time we have a 90-degree angle between two vectors is when the dot product is equal to 0. We're going to use that fact here to find a value for t, to find the value of t that would make p and q perpendicular to each other. So 3, that means p dot q equals 0. So 3 times negative 2 plus t times 1 equals 0, and we can go ahead and solve for that. Negative 6 plus t is equal to 0. That means that t has to equal 0. It's as easy as that. Okay, so I want you to try this one. find t so that if a equals the component form of -1 and 5 and b equals 2 and t, find the value of t that's going to make those perpendiculars. So turn this off and restart it when you're ready to check your answer. Okay, check your answer. Hopefully you got it right. You can pause this if you need to while you're checking your answer. Alright, my second example is I want to find all vectors that are all forms of a vector that are perpendicular to 5, the vector 5, 2. Well, you have to think about this one for a minute. That means that 5 times the x component of some vector, we'll call that bx, plus the y component of some vector has to equal 0. It's really quite easy if you think about it. If I just use these as common factors, then 5 times 2, or -2, plus 2 times 5 is going to give me -10 plus 10 equals 0. So my other vector would be -2 and 5. One of these has to have the opposite sign of one of these in order for this to work. In fact, remember that all vectors that are parallel, any vector that's multiplied by a scalar, they're all parallel to this. So let's check that out. Let's say that we want the dot product. Let's say that A is 5, 2, and B equals 3 times, I'm just picking 3 as a value for k, -2, 5, just to show you that all vectors will be in this form. That means that 3b is -6 and 15. Not quite so obvious that the dot product here will be 0, but a dot 3b is going to equal 5 times -6 plus 2 times 15, which is -30 plus 30, which is 0. So any scalar multiplied by our first vector here is going to give us a dot product of 0. Here's one for you to try. Find all the vectors that are perpendicular to the vector 3, 4. Stop this and turn it back on when you're ready to check your answer. Okay, hopefully you've got the right answer. The vector is k times the vector in component form of column form, sorry, of -4, 3. And k, by the way, I forgot to mention that k can't equal 0 because then you don't have a vector. You have the 0 vector. Alright, so I have a 2-point bonus for anyone who wants to write this up. Why is this true? And you need to write out a clear and complete explanation with possible diagrams to show why this is the case and turn it in next class. Notice that if you test it out, if a dot b, or notice that as a dot b is equal to the magnitude of a times the magnitude of b cosine theta, that if the cosine of theta is greater than 0, then your angle is acute. If the cosine of theta is less than 0, then your angle is obtuse. So that means that the dot product a dot b is greater than 0, then the angle is also acute, and if a dot b is less than 0, then your angle is obtuse. Explain to me clearly why that's true, and I'll give you 2 bonus points on one of the classroom quizzes. Okay, so my third example is we want to find the measure of angle ABC. I'm going to put a grid here. We have 3 points. We have A is at 3, 1, B is at 1, 2, and C is at 4, -1. And I want to find the measure of the angle of ABC. It means that B is in the middle. I think that's supposed to say, nope, that's right, angle ABC. Okay, so this would be point B, and that would be the angle that we're looking for right here. All right, so first I'm going to find the vector from B to A. If I'm going from B to A, that's going to be 2, -1, right? I have to go, I can use the formula x2 minus x1 over and y2 minus y1, but I prefer to think of it as to get from B to A, I have to go to the right 2 and down 1. And then if I want to find the vector from B to C, well, from B to C, I'm going to the right 3, and from 2 to -1, I'm going down 3. So that's my vector for B to C. Now that I have those, I can find the dot product. BA dot BC is going to equal 2 times 3 plus -1 times -3, which is going to give me 6 plus 3, which is 9. The other thing I want is the magnitude. The magnitude from B to A is going to be the square root of 2 squared plus 1 squared, which is the square root of 5. And I also want the magnitude of B to C. And that's going to be the square root of 3 squared plus 3 squared, which is the square root of 18. Okay, so to find the angle between two vectors, it's cosine theta equals the dot product. So that would be 9. We've already calculated that up here. BA dot BC times the product of the magnitudes. We've already calculated both magnitudes. They're radical 5 and radical 18. So cosine theta equals 9 over radical 120. Now I can go ahead and find the angle. The angle is arc cosine of 9 over 120. And that gives me an angle of 34.8 degrees. So that's the angle between those two vectors. Now it's your turn. You guessed it. Turn this off, try this out, come back when you're ready. Okay, hopefully you got the right answer. You should have gotten somewhere around 64.7 or 65 degrees. Let's move on. There's at least one more kind of problem you might see on the test and might not know how to do. We want to find the measure of the angle between the lines 2x plus y equals 5 and 3x minus 2y equals 8. So that's two lines that we want to see what the angle between those two lines are. Let's give this a shot. Okay, so we have these two linear equations. The first thing I'm going to do is put them in slope-intercept form. So 2x plus y equals 5, then y equals negative 2x plus 5. My slope here is negative 2 over 1. I go down 2 and over 1 for every unit. Okay, and then the second equation, 3x minus 2y equals 8, if I rearrange that into slope-intercept form, or not, yeah, slope-intercept, then 3x minus 8 is equal to 2y. That means that y equals 3 over 2 x minus 4, which means my slope for this one is 3 over 2. Why is that so important? Well, if you think about slope, slope is the change in y over the change in x. When we write, and that's really what a vector is, but when we write a vector, it has the slope of a line is not a vector unless the vector is a line segment, but when we write a vector in column form, we write the change in x over the change in y, like this. So the first vector here for this first line, we can write as 1 over negative 2. And then the second vector we can write as the change in x, which is 2, over the change in y, which is 3. So now I have two column vectors, and I can use all of the math I used before to find the angle between two lines. And now that I have that out of the way, I'm going to erase some of this stuff because I'm probably going to want to go back and draw you a picture of this. But those are my two vectors that I need to find the angle between. Okay, so it's going to be cosine, that's the eraser, cosine theta equals, we'll call this A, we'll call this B, A dot B over A magnitude, A times the magnitude of B. So A dot B is going to equal 1 times 2 plus negative 2 times 3. So that's going to be 2 minus 6, which is negative 4. Now all we need are the magnitudes. The magnitude of A is going to be 1 squared plus 2 squared, which is radical 5. And the magnitude of B is going to be 2 squared plus 3 squared, which is radical 13. Okay, so that gives me an angle where the arc cosine is negative 4 over radical 65. That gives me an angle of 119.7 degrees. So if I draw this out, I'm just going to draw a really crude graph here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I really should have put a graph in here, but you're going to get the idea anyways. My first equation was, in slope form, was negative 2x plus 5. So the intercept was 5, and I would go down 2 and over 1, down 2 and over 1, and I could plot this line something like this. Okay, and then the second one, the intercept was negative 4, and I moved up 3 over 2, so 1, 2, 3 over 2, and I could plot this line. This angle here clearly goes with this angle here, and we still have one angle here to consider. To find that angle, I simply use 180 minus 119.7, and that's going to give me an angle of 60.3. So those are the two angles between those two lines. And thanks for bearing with me. I know it's been a long haul. For me, it's time to go back to the laundry.